I am Dr. Saroj Hole. I will teach you superposition theorem. So first we will see the definitions. So definition of a network. It is a combination of components connected in any way. Definition of network theorem. For analysis of a network, one needs different rules. They are known as network theorems. Network theorems are shorter methods for solving the circuit. By using network theorems, one can convert complex circuit into simple equivalent circuit. Now we will see the statement of superposition theorem. A superposition theorem for electrical circuit states that for a linear system the response, that means voltage or current, in any branch of a bilateral linear network having more than one independent sources equals the algebraic sum of the responses caused by each independent source acting alone when all other independent sources are replaced by their internal impedances. See what it means in this circuit or in this theorem. When more than one voltage sources are connected, you can find out the current in different branch and voltages in the different branches by replacing one voltage source by short circuit. To ascertain the contribution of each individual voltage source, all the other sources first must be turned off. That means set to zero. By replacing all the other independent voltage source with a short circuit, that means thereby eliminating the difference of potential. It means V is equal to 0. Now internal impedance of any ideal voltage source is 0. Okay. Now replacing all other independent current sources with open circuit. If in case instead of a voltage source there is a current source in the circuit, then you have to replace it by open circuit, thereby eliminating the current. So I is equal to 0. Now internal impedance of ideal current source is infinite because it is an open circuit. Now theorem is applicable to all linear networks. They may be time varying or they may be time invariant, consisting of independent sources. Linear dependent sources. Linear positive elements like resistor, inductor, capacitors, transformers, they all are linear components. Now another point that should be considered is that superposition only works for voltage and current but not for the power sources. So whenever there is a power source in the circuit, you should not apply this theorem. Now we will solve this example using superposition theorem. So you will get a clear idea about the theorem. So using the superposition theorem, determine the voltage drop and current across the resistor 3.3K as shown in the figure. So here in this circuit, 8 volt and 5 volt are the two batteries and 2 ohm, 4.7K, 3.3K, all these are the resistors connected in the circuit. So what is the step 1? First we will remove the 8 volt power supply from the original circuit by short circuit such that the new circuit becomes as the following, and then measure the voltage across the resistor. So what happens here? 2K and 3.3K, they are coming in parallel, and so you have to find out R1 into R2 upon R1 plus R2 and then connect in series with 4.7K. So what will be the current through this 3.3K? So when 3.3K and 2K are in parallel, what is the total resistance? 1.245. Using voltage divider rule, voltage across 1.25K will be 1.05047 volts. Now step 2. Remove the 5 volt power supply from the original circuit such that the new circuit becomes as the following, because 5 volt is removed by short circuit. Then measure the voltage across the resistor. Now in this case what happens? 3.3K and 4.7K, they are coming in parallel and in series with 2K. So you can find the current due to 8 volts. So here 3.3K, 4.7K parallel combination, you will get 1.938K. Using voltage divider rule, voltage across 1.938K will be V2 is 3.93. Therefore voltage drop across 3.3K resistor is V1 plus V2, that is 4.98. Now assignment is given. Solve the given problems and submit it next week. Solve it in your assignment notebook. Now in assignment question 1 is using superposition theorem, calculate the current in each branch of the network. So there are two voltage supplies are there, 24 volt and 12 volt. So solve it. Now question 2, you have to find out the current through 20 ohm resistor. It's very simple. Now using the superposition theorem, in question number 3, find the current through 8K. Here something different is, instead of a voltage source, second source is current source of 12 milliampere. Okay, so you have to replace it by open circuit, and then as is done in previous cases. Now in question 4, use superposition theorem to find the current through R3. It's very simple. 32 volt and 20 volts are given as voltage sources. Okay, so in question 5, state superposition theorem. Using it, calculate the current through 3 ohm resistance. Okay, so 6 volt and 12 volt are two different sources.